Hey guys, so in this one we are doing some error intervals past paper exam questions. These are nice easy marks. They have come up every single year so far for both foundation and higher. So we absolutely want to make sure you can do them. Download the questions from the description and let's do this. So, first off, it seemed like a good idea to explain what error intervals are because nobody ever knows. So, whenever you round a number, you are making an error. So, after a number has been rounded, called the number x, its error interval is a double inequality. The lower bound is the smallest number x could have been before it was rounded, and the upper bound, which is a strict inequality, I'll explain why in a moment, is the smallest number x could not have been before being rounded. So, for example, my age rounded to the nearest 10 is 30. So the error interval of my age, if we call it x is greater than or equal to 25. I could be 25 and my age would round up 30, and then the upper bound is 35. So my actual age has to be less than 35. So my actual age could be anything from 25 up to just less than 35. Alright, so that's all that error intervals are. Let's just have a quick look at why we do what we do with the upper bound. So, back to my age, it's still greater than or equal to 25, that's fine. Say that then, we said it was less than or equal to 34. So 34 is fine, that would still round down to 30, but then it can get a little bit silly. So I could say 34.9. 34.99, 34.999, etc. So to cut out that silliness, that is why we use the strict inequality with the first number x cannot be. Okay then, here we go. So the length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of the pipe. So the shortest the pipe can be would be 5.5 meters, and the shortest the pipe cannot be would be 6.5. Because that would round to 7. Okay, then for part B, the length of a different pipe is 4 meters to the nearest meter. Ollie says the total length of the pipes is 11 meters to the nearest meter. Give an example to show that Ollie could be right. So, the first pipe could be 6.4 meters. The second pipe could be 4.4 meters. Now together then, that would give us 10.8 meters, which, rounded to the nearest meter, is indeed 11 meters. Okay, next up, the side length of a regular pentagon is 8.4 centimeters to 1 decimal place. Complete the error interval for the length of one side. So the smallest number that would round up to 8.4 to 1 decimal place is 8.35. Now the smallest number that doesn't round down to 8.4 is 8.45. Okay, and then we want to complete the error interval for the perimeter. So a pentagon has 5 sides. If it's irregular, all sides are the same length. So for our lower bound, we do 5 times 8.35. Now that gives us 41.75. And then for the upper bound, we do 5 times 8.45, which gives us 42.25. Okay, next up, the length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. So, the shortest it can be to round to 110 to the nearest centimeter is 109.5. The shortest it can't be would be 110.5. Okay, next up, Sally used her calculator to work out the value of the number y. The answer on her calculator began 8.3. Complete the error interval for y. So, if the number begins 8.3, it might stop there. So the smallest number this could possibly be, because the calculator starts 8.3, is 8.3. Now, the smallest number we know the answer can't be is 8.4. Okay then, next up, slightly different here. So, to the nearest pound, John has £9. To the nearest 50p, Ellie has £6.50. We are asked to work out the maximum possible total amount of money. So, because we're doing error intervals, let's do the error intervals for each of them. Now, because money can only end in a certain amount of pence, the upper bound here can actually be or equal to. Because there's no silly 0.99999 going on. So the smallest amount John could have would be £8.50. Now the greatest amount he could have would be £9.49p. So he could actually have £9.49. Then for Ellie, to the nearest 50p, the smallest she could have would be £6.25. And the most she could have, well, £6.75 would round to £7. So the most she can have is £6.74. So the maximum total is £9.49 and £6.74, which gives us £16.23p. Okay, now the final page. The height of a tree is 12 meters, correct to the nearest meter. Circle the error interval. So the shortest it could be is 11.5. The shortest it can't be is 12.5. So it's this guy in the top left. Okay, now for the final question, we have something slightly different. So Martin truncates the number n to one digit. His answer is 7. Write down the error interval for n. So if you truncate a number here to one digit, then it means after the first digit you just cut off anything after. So for example, here n could be 7.92156, truncated to one digit, we just cut off all of that stuff. So the error interval then is that n has to be greater than or equal to 7. Now it has to be somewhere between 7 and 8. So the upper bound is 8. Okay then guys, that's error intervals, so I really hope you found this useful. If you have, please do give us a thumbs up, subscribe to the channel, share with your friends. Remember, there are playlists in the description full of downloadable exam questions like this. Any requests, let me know in a comment.